Okay, in this video we're going to continue with where we left off in the last video, and that is working on the Model.cpp file. It's now time to go ahead and get our materials loaded.
Right. So we're going to go down to our load materials section here. Dun, dun, dun. Remember, this is going to be called inside of our load object called load materials, and that's where we handle loading the MTL file. So if I just go down to my load materials section, let's go ahead and get started by doing our load file. So ifstream istr, I just indent that in. So our file name .data, and make sure we've loaded the file properly, exactly what we did
Right.
in the and in fact, if I just go up real
go back
quick.
down real quick.
Yeah.
I was just looking at your code. Throw an I in there.
Oh, thank you.
Not a problem.
Awesome. So let me just go up to here. Let me just copy this whole path thing. And we're going to do exactly the same thing here.
Precisely.
Because we need to load textures and such. So let me go ahead and throw this in here. So we got our path. Now let's go ahead and do, again, exactly the same thing we did before. Amazingly enough. Basically our current material, I'll just call this material. And then we're going to need a character line array, so that we can do a loop that gets every single line of our material file. So we have our line, get 256 characters.
And here we go with the heart of this part.
Yep. And so we get our iString stream, just
Same
like we
thing.
did in this last one. So let's get our first word in here. So first word and new line. First word, just to stay consistent with what we've done before.
And if you want to take just a second right above the while loop, just write out a quick little example of what one of these look like.
Sure.
How we've got KA, KD, etc.
Right.
Let's see, just looking around, seeing if I happen to have one readily available, so we don't have to rely on memory.
Yeah. So basically what we have is a series of new material calls. So like new MTL, my material 1, and then later on in the file, my material 2. And then between each of these calls, it sets the different values for each of these. Like illumination is 4, KD will be set to say 1.0, 1.0, 1.0. And we need to read each of these in.
Exactly.
And then the same thing for the bottom one here. It would have something similar to this. Maybe this illumination is 3. It's some sort of greenish color or something, or something like that.
Okay.
So basically, it would have first you have a new material which specifies, okay, we need to create a new material with this name, and then following that, until the next new MTL call, set its attributes.
Right. So we're going to be looking for like illum, KD, KA, TF,
Yep.
NI, KS, and NS.
And yep, exactly. So the first thing we're going to do is actually check for a new material. So if first word equals new material, as we just saw, then what we're going to need to do is create our material. So do a material equals new material, a new struct.
Okay.
And then we're going to push this onto our stack, so push back our material. And then get our name for our material. Or actually, we can simply specify this into our material. So our material name, new line, and just pump that directly into our material name. Because like I said right up here, the material name comes right after our command here. So we can simply do new line and pump that directly into our material name. And so that's all we need to do there. Now we have all the things that we need to get from this file. So a whole bunch of else ifs here. So if the first word equals illum, get that. And then if we need to get our
KA,
KD,
KS.
let me just go ahead and put all of these in. KD, KS.
KE.
And actually, let me pause for just one second and fill one of these in, because you'll notice that even the guts, if you will, of this code is the same. So we'll just do a new line and then pump this into our material illum. And then for our KA, simply new line, material KA, the 0 index to this array, material KA. And inside of our OBJ, it only has 3 elements that is saved. So
right.
K1, And then material.
As opposed to the 4 that we've become quite accustomed to working with throughout the OpenGL VTM.
Right. And then we're just going to copy and paste this for our KD and KS. So KD and KS.
Yes. Nice and simple.
And then we have pretty much the same thing for quite a few of the other ones that we have. We have our KS and KE. So we have our KE, and this one's just KE.
Emissivity.
And then we have our emissivity.
Shininess.
So let me put this as...
Oh, okay, no, you still haven't done that one. Huh.
You talk faster than I type.
Actually, yeah, shininess.
Let's see. Shininess. And then we have alpha. So this one's... for alpha, there's 2 words that it could use, either D or it could use TR. They're both the same thing, but different exporters will use different conventions. So just make sure your exporter supports both. And this just simply pumps into the materials alpha.
Simple enough.
And then we could also have a 3-channel...
our color alpha.
Right, a color alpha. And all we're going to do is convert this into a regular alpha by taking the average intensity of that color. So this is going to just be TF. And we could get thank you. And so a vector 3, we could call it color. This is our color transparency. And then get our new line. So just new line, color.x, color.y, and color.z. And then we'll set our material alpha to equal...
Yeah, just add them all and divide by 3. It's
right, get the average, yep.
That's it.
Which is the average intensity. So we're converting it to grayscale in a way. So we've got that. Now we need to get our maps that we have. If we look back into our material here, you notice we have all of these maps that we need to get. So we'll do another else if and say if first word equals map underscore KD, KA, then go ahead and load in that texture. So get the file name first, new line, file name, and create our new texture map. So map equals new texture string path, which we created above, and we're going to add on to it our file name. And then simply do our material ambient map.
And we're using our texture class that we've created ourselves earlier. That's really important.
Yeah, very, very important to know. And did we already include... Yeah, we did.
Yeah.
Simply because we've defined it here.
Mm-hmm.
So let me go ahead and copy and paste this several times. So we got our map KD, our KS, our KE, our shininess map. Let's see.
Let's see, we got transparency, bump.
And that's it. So let me go all the way back up here. We just pasted a lot of code here. So we got our ambient, our diffuse. Let me just change this to diffuse map. And we have our, let's see, specular, right?
Mm-hmm.
So we have our specular map. We also have our emissivity.
Yeah, we have our
emission map. Is this our emission map after this, or?
Hang on, let's see. We got KD, KS,
yeah, we need
KE,
our emission map.
And then
emission
NS.
Map. KE, so
NS.
we have NS, map NS. And this is going to be our shininess map, right?
Wait a minute. Making sure we don't lose track of things here. We may end up with
this
one
is
too many.
shininess map. Yeah, I may have typed in one too many, but that's okay.
That's all good. Let's just verify, though. So starting at the top with KA.
So I have KA, KD, KS, KE.
Right.
Shininess map.
That's right.
We also have our map underscore D.
Beautiful.
Which is going to be our transparency map.
Mm-hmm. And then we have the bump map.
Now we have our map bump. And this one's going to be our bump map.
Perfect.
Awesome. So there we have all the things we need for loading our materials.
Okay. Whew.
Not too bad.
No.
So at this point, what we need to do is actually create our draw code. So if I shoot all the way back up to the top here, we only have 3 functions remaining: draw model, draw object, and draw face. And we'll just kind of implement this in the same order that they're listed, simply because, well, we listed them in that order because it makes sense.
Right.
So the first thing we're going to do is do our draw model. And for this one, the first thing we need to do is check to see whether or not the object has been loaded.
Exactly.
So if object is loaded, draw model. So if the object has not been loaded, go ahead and return. And then if the display list, remember we have our display list, if that does not equal 0, in other words, we do have a display list, we'll simply call our display list. And then just return.
Right.
Otherwise, we need to actually create our display list. So I'll do a create gen lists and simply create one new list, and then start creating our new list. So our display list, and GL compile and execute. And what I'm going to do now is basically call our draw object false and true. And remember, as I said, we have two passes to our draw object, one in which we don't have transparency and one in which we do.
Right.
So we're going to have our draw object false and draw object true. And then once we're done with that, we'll do an end list. And at this point, let's go ahead and go to our draw object.
Okay.
And, well, draw our object. So the first thing we're going to do is create a last material. Or actually, let me create a giant loop that loops through every single object. So I equals 0, I is less than all the objects. So objects.size.
Don't worry, guys. He's coming back to that last material he just mentioned.
Yeah, I'm going to come back to that. I just need to kind of block this in first so you see exactly our flow here. So let's create a group object that's going to store our current object that we're looking at. And that's simply objects I. And then we're going to need to loop through every single face. So int n equals 0, n is less than int object dot faces dot size n plus plus. And then simply loop through every single one of the faces. So face is face equals object dot faces n. And then we need to get the material for that face. And just to make it a little bit simpler than having to type out face, arrow, material, we'll simply create a material equals faces material. Just a little less to type because we need to use it quite a bit. And then the last material, basically, we have to set our material, right?
Right.
We have to call our GL material FV over and over again. And if we were to do this for every single call, that would be terrible because it would just slow down our overall code extremely. So what we're going to do is create a material pointer, last material, and store which is the last material that we apply to our object. And whenever the material is different, we update the material. Otherwise, we keep using the same one.
It just keeps us from having to do that extra call.
Exactly. Well, actually, quite a few extra calls.
Right. That extra, what's the word I'm looking for? Mm-hmm. That extra set of calls.
Yeah. So if
there's still another word I was looking for, but I just can't find it.
Oh, well.
Yeah.
So basically, if the material does not equal last material, go ahead and draw it, and then update. Go ahead and update our material and update our last material.
Right.
So inside of here, we're going to make sure, first off, if this material is partially transparent, if transparency equals false, what was passed to us, and our material's alpha is actually less than 1.0, in other words, it's not completely opaque, then go ahead and continue, because I don't want to draw this particular face.
Right.
Or this particular material. And then at this point,
yeah, here comes the bunch of calls I was talking about.
Right, we have our GL material FV calls that pass our diffuse, our emission, shininess, and specular. So we have our GL material FV, and we want to apply this to our front and back surfaces.
Right.
Front and back.
And GL diffuse.
Mm-hmm. And we're going to pass it what we've created here. So we're going to cast it over to a float and simply pass it KD. Also, though, the last channel inside of our diffuse is going to be...
You need...
Yeah.
Set all, making sure you add all the... Okay.
Okay. So our material KD, the fourth element is equal to our alpha. So let's go ahead and set that over to alpha. And then simply set the material.
Okay.
And then let's go ahead and copy and paste this. GL specular. And this one's going to be GL emission. And this one's going to be GL shininess. And I'll need my ambience as well. So let me copy and paste this one more time. And let me set this one to GL ambient, since we've kind of been doing in that order. So our ambient, diffuse, specular, emission. And then for our shininess, this is simply one float. So we're going to change this from FV over to F, and then change this from that over into our shininess. And also we need to set up our diffuse map. So let's do if material diffuse map does not equal null. So we do have a diffuse map. Then go ahead and GL enable GL texture 2D and bind this texture. So bind texture GL texture 2D over to our materials diffuse map and get his text ID. So basically inside of our diffuse map, which is our texture class, we have a text ID which allows us to, which stores which ID is associated inside of OpenGL with our particular texture.
Right.
And it's already been loaded, so all we need to do is bind it to that texture. And otherwise, if it doesn't have a texture, go ahead and disable textures. So DL disable texture 2D. And this is where I was saying if you want to extend it to support
other maps
like an ambient map, specular map, emission map, whatever, you could go ahead and throw it in right here.
Exactly.
And with that, finally we just need to call it. So draw face and pass it our face. So done. Is there anything else?
No, I think you've got everything in there.
All right. So at this point, what we need to do is call our draw face. Draw face is very, 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 very small. If we just come down to our draw face here. First off, we're going to check how many vertices we have and call GL begin with GL triangles or GL polygon dependent on that. So we have our face.num vertices. If that is less than or equal to 3, then we'll do a GL begin, GL triangles. Of course, if we actually do have less than 3, this is not going to work either. Because with 2 or 1, the vertex is not going to, the triangle polygon is not going to get called.
Exactly.
Otherwise, we're going to do a GL begin, GL polygon.
Right.
All right. So at this point, we need to loop through every single one of our vertices and actually draw it. So what we're going to do is do a GL vid v is less than int face.num vertices v++. And then we're going to make sure that we have enough. Basically, we need to set up our texture coordinates, our normal, and our vertex for this. So we need to check each of our num UVs, our num normals, and num vertices before actually calling each of those calls. Otherwise, we might outstep our boundaries because we may not have, as we saw before, a UVW for a particular one. So let's check to see if the num UVWs is greater than V. And then if it is, and his face.UVWs does not equal null, because if we didn't even initialize it by some fluke, we need to make sure we don't try to call either, because that'll just generate an error. So then we just call our GL text core to F and pass it our face.UVWs, V, and pass it X, and our face.UVWs, V, and pass it Y, our S and our T. Let me just copy and paste this 3 times, because basically we have the same thing here. We have our GL normal 3D, and our GL vertex 3D. And we simply need to pass it for here. We need to pass it our normals for our X, Y, and our Z. So for normals for our X and Y, and finally normals for our Z. So pass it Z. And then for this one, same general idea, except we need to also pass it the vertices of our Z component. And this one's going to be num vertices. And this one's going to be vertices. And this up here is going to be normals, just kind of filling in the gaps that I just created. So num normals.
Copy and pasting.
Yep. So with that, notice we have one call that sets our texture coordinates, another call that sets our normals, and finally a call that sets our vertices.
Right. Now, of course, with the GL begin, we need a GL end.
GL end. And with that, that should be everything.
Okay, except for, back over in the header file, we're now using a bunch of OpenGL stuff. Yeah,
we are doing a bunch of OpenGL stuff. So basically what I need is to be able to have an if not defined, like we showed you many times before, that basically allows us to define our OpenGL header files and define our windows.h file if we're using Windows.
Right.
So what we need to do is do, at the very top here, as you've seen many, many times now, our if define win32, we'll go ahead and define our win32 lean and mean, and then we're going to include our windows.h and endif. And then we have the same thing. We need to include our OpenGL headers. So we have our GL include gl.h and our include glu.h. And then a special one for either Apple or Mac users, which will allow us to have, those platforms supported as well. So if Apple is defined and mock is defined, then go ahead and include it differently. So OpenGL.gl.h and include thank you, OpenGL.glu.h. Else, include it the regular way, and end if. Let me just clean that up a little bit. So there you go.
Cool. Whew.
Wow, that's a lot of coding.
I think
that's everything. And again, in the next video, we're going to be tying everything together and kind of compiling it, working through all the errors that we may have. And
we may actually just divide it up. In the next video, we'll make sure that all errors and everything are out of the way.
Okay.
Just a really short video.
Sure.
And then move on from there.
Cool.
So with this, that's basically all the foundation and nuts and bolts in place now. So that's going to wrap up this video. Thanks a lot.